各位老师好，各位同学好。然后我现在先共享一下我的屏幕。嗯，好，大家可以看到我的屏幕吗？
好，
嗯，
可以看到哈，王博士可以看到。
好的。那么就是在这个我 present 过程中，如果说大家看不到屏幕或听不到我的声音的话，请随时打断我。那么首先我将进行一个简单的中文自我介绍。嗯，我博士即将毕业于英国南安普顿大学，然后我的研究方向正如这个吴老师所说，是专注于中国宏观经济、劳动经济和国际金融。那么我在这个嗯开发和研究这个搜寻与匹配模型和 DSG 模型上，都有一定的经验。同时的话，我也积累了非常多的这个就是专业知识在这方面。那包括这个开发模型、求解模型和估计模型。那么我的博士生导师的话，他Circuit Stepanchuk 他发表了很多Journal of Monetary Economics 和 Journal of International Economics。目前的话，我和他在合作了一篇论文，同时也有一篇论文正在研究过程中。那么将来的话，就是我的目标就是说和他进行更多的合作，然后把自己的研究成果发表在这个国际高水平质量期刊上。那么我目前的两篇工作论文，我目前完成了3篇工作论文。那么其中2篇的话，在多个国际和国内的学术会议上进行过汇报。那么我的这个 job mark paper 就是 Gender Imbalance 这篇的话，它主要是研究这个 consequences of 这个就说男多女少对这个婚姻市场匹配和这个中国家庭收入不平等。那么他在这个第5届暨南大学的这个经济与社会研究中心和全球劳工组织的这个国际会议上进行过汇报，同时也在这个剑桥大学的Genuine Institute 进行过汇报。那么第2篇论文是在研究是中国资本管制和这个货币国际化这2者之间的关系。那么他在这个中国世界经济学会国际金融论坛上和中国人民银行金融研究所上进行过汇报。那么这2篇论文的话，我的 job mark paper 计划近期投稿到Journal of Development Economics 上。那么第2篇论文计划投稿到 China Economic Review 这篇期刊上。那么下面我将开始我的这个正式的 job mark paper 的汇报，然后我将采取英文的汇报方式。Okay, many thanks for inviting me to attend this interview. And today I'm going to present my job mark paper. So the title is Gender Imbalance, Assorted Matching and Household Income Inequality in China. So before I officially introduce the contribution and the research questions, I'd like to give some motivation and brief introduction about this project. So the match market matching outcomes have important implications for economic development. And the household sorting in marriage affects the human capital accumulation, income inequality, and the labor force participation decisions. And one of the important determinants of the match market matching outcomes is the sex ratios. So this is the ratio of males to females in the population. And the relevant literature can be found from Abramitsky and Angrust and Du and Wei and Wei and Zhang. So it's often argued that there is a growing trend of assorted marriage, that is likes marry likes across countries. If we look at the data from the United States, UK, Germany, and Denmark, we found as time forward, there is a growing trend of the assorted marriage. And this is positively associated with the increase of household income inequality. And this comes from two empirical facts. First one, the proportion of couples they have the same education level has been growing. Thus, we call it as educational homogamy. And secondly, accompanying this increasing education homogamy, we found there is a rising household income inequality. And this phenomenon are documented in those literature, especially in Chapori, Aika, and Fernandez. So by using the population census data from 1982 to 2015, I plot the sexual issue at birth of China. And I divide the sexual issue at birth into three regions, at the national level, rural level, and the urban level. I found as time forward, there is increasing trend of the sexual issue at birth. So this implies that as time forward, there is a more severe of male abundance in China. So in this paper, we are going to start three research questions. The first one is, what's the effect of rising sexual issues on matching outcomes in the Chinese marriage market? And the second one is, we want to study how does the sexual issue affect household income inequality. And lastly, we want to see how the sexual issue affect education attainment for men and women. So this project, we make three contributions. The first one is we empirically examine the relationship between sexual issue and household sorting by using the individual level and the regional level data. And the second contribution is that we employ a heterogeneous agent search and matching-based gender equilibrium model to study the interaction between sexual issue and household income inequality. And lastly, we endogenize the education decision for males and females before they enter into the marriage market. And we want to see how would they respond differently before they enter in the marriage market. So the previous literature focused on evaluate the sexual issue on the increased crime rate, see Adlon inter alia, and also the sexual issue increased household saving rates and housing expenditure. So the rising sexual issue caused family with son to save more and purchase more expensive houses. And also they studied the sexual issue on the effect on the sexual issue on match market and matching pattern. So the female abundance result male hypergamy, which can be found from Abramitsky, Angrust, and Du. So another strain of the literature studies assorted matching and income inequality. As the first paper comes from the Baker, they indicate that economic better off agents tend to marry each other. And Alka and Greenwood, Fernandez, they document in most countries, there is increasing trend of positive educational assorted matching over time. And this lead to a rising of household income inequality. And few studies have examined the interaction between the sexual issue and assorted marriage. So we firstly employ the empirical evidence to study the effect of sexual issue on the assorted matching and the effect of sexual issue on the household income inequality. So the data come from three sources. I employ 3 waves of CHIEFS data and several waves of China City Statistics Yearbook and also the population census data to run 3 different types of regressions. And in the sample, we restrict the sample, the cohort whose age are between 20 to 30, and they resident in the urban area. So the sexual issue is defined over cohort, prefectures, and year. If I use the population census data of 2010, I plot the sexual issue across the prefectures. And the darker side stands for the more intensive of the male abundance. So from this figure, we know the sex ratio is heterogeneous across regions in China. So firstly, I run 3 types of regression. The first regression is baseline regression. I want to study how the sex ratio in the region affect the regional education correlation between couples. And the second regression and third regression serves as a robustness checks. So in the baseline regression, we found that with the increasing of the sex ratio and education correlation between couples is negatively correlated. And in the robustness check, I use the interaction term to study the marginal effect of husband education with the marginal effect of wife's education with respect to husband education. So I found with the increasing of the sex ratios, the marginal effect it decreased. So this also implies that the sex ratio and the household the degree the assorted matching is negatively correlated. And lastly, I use the education distance between the couples as an alternative measure on the education correlation. So I run the regression. I found with the increasing of the sex ratios, the education gap between the couples also increase. So this also implies the sex ratio and the assorted matching is negatively correlated. So to resolve the potential endogenous issues, I use the instrument variables of the sex ratios, and the data collected from the Epstein published in 2010. They use a monetary penalty for violating the birth quotas in provinces. So this is to measure the intensity of the enforcement of one-child policy. So in the IV result, I've also found the sex ratios is negatively correlated with education correlation between couples. So following up, I want to study how the sex ratio affect household income inequality. So I firstly use net labor individual labor income, and I construct 2 measures of the income inequality. The first one is the Gini coefficient, and the second one is couples which at different percentile their log ratios. So for instance, in the 80 percentile and 20 percentile. So I run a series Tobit 1 models. So I found the household sorting is positively related with household income inequality. And the sex ratio, and I also study how the sex ratios affect the income inequality. I found a negative relationship. So the sex ratio is negatively affect the household income inequality in China. So basically from the empirical result, I found that the sex ratio in the marriage market and couples education correlation, they are negatively correlated. And the higher sex ratio increase the education distance between couples. So this is robust and this is consistent with the baseline result. And I also found there is a positive association between assorted marriage and household income inequality in China. So in short words, I found a higher in the regions with higher sex ratios. So this means in the region of more male abundance, we have lower degree of assorted matching. So motivated by the empirical evidence, we develop a heterogeneous agent search and matching-based general equilibrium model to provide a structured interpretation on the empirical result. So we want to inspect our mechanisms that why the sex ratio is negatively correlated with assorted matching. So in the model part, we assume the economy is populated by agents with two different genders, either male or female, and they live for 3 periods. In the first period, the individual can decide to become either skilled or unskilled. So we define the skilled individual as who have the above high school education level. And in the second period, individuals finish education and they enter into the marriage market, meet with opposite gender and with the characteristics, either skilled or unskilled agent. So in the marriage market, they meet with each other and they infer the agent's future income, and they draw a match-specific quality. So the match-specific quality can be understood as love. And in the last period, the agents work and consume their income. So following Fernandez et al. Published in QJE in 2005, we assume that male and female, once they form the household, they form the family, they share a common joint utility function, and they derive the utility function from the consumption in the last period, and also from the match quality of his or her. So the indirect utility function V equals to the payoff come from the consumption of income plus the match quality that this agent perceived. And the utility function we assume is a continuous and strictly increasing function of the household income. So the household income will be the wage of the skilled male plus the wage of skilled female, or either the wage of skilled male plus the wage of unskilled female. So as we have two opposite genders and we have two types of education, so thus we have 4 types of agents in the model. And the combination forms the 4 types of the household income. So in the match market matching process, there are 2 rounds of match in the match market. So in the first round, individuals, they meet randomly and they draw a random match specific quality Q, where the CDF function is QQ. So this match can be accepted by both agents. So if they accept this match, they get married, or they can be rejected by at least one of them. So if one party of the couple reject this match, they go into the second round. So here I use a Q bar to stand up the cutoff match quality for a person of the gender G, and in a meeting type, either skilled male meet with skilled female, skilled male meet with unskilled female, unskilled male meet with skilled female, unskilled male meet with unskilled female. So we have 4 types of meeting. And below the cutoff match quality, the person will not want to get married. Here, so we define the probability of a type SS. So this is a skilled male and a skilled female. The probability of this type of meeting they get married in the first round equals to the probability that the male perceived match quality is larger than the cutoff match quality of him, and cross the probability that the match quality the female perceived, and that is larger than the cutoff match match quality he perceived. So we define the probability of get married equals to this part. So in the population, we assume that the number of females in the population is exogenous. And we define the number of males in the population equals to 1. We use the psi to stand for the share of skilled male in all males, and we use psi f to stand for the share of skilled female in all females. So in round 1, since the number of males is larger than the number of females, so some men will not meet a partner and they in the first round, so they will directly go into the second round. So there will only be a number of females meetings. So we define the different number of meetings over here. That is the number of females times the share of skilled female times the number of males times the number of skilled male. Sorry, times the share of skilled males. So here it's the number of meetings for the skilled male and the skilled female. So we do the same thing for the other number of meetings for the different types of agent. For instance, we want to find the number of meetings for the unskilled male and unskilled female. So it equals to the number of males times the share of unskilled male times the number of females times the share of unskilled female. So over here, we have defined the number of meetings. And the following, we define the number of unmatched individuals after the first round of matching. So I use theta g to stand for the number of unmatched individuals of gender either male or female and the skill type after the first round of matching. So we have the number of unmatched skilled male equals to 3 components. So the first component corresponding to the actual skilled male, because we have more males in the population. So this number of skilled male, they cannot meet anyone, and they directly go into the second round matching. Plus the number of unmarried skilled couples. So we have the number of meetings times the probability that they reject this type of matching. So we get the number of unmarried skilled couples. The number of unmarried skilled males, and they go. And this type of agent, they go to the second round of matching. So we also have another case is that the skilled male meet with unskilled female, and if they meet with each other, however they reject this type of match, then the skilled male will be unmatched, and he go to the second round of match. So we do the same thing for other types of agent. For the number of unmatched unskilled male, the number of unmatched skilled female, and the number of unmatched unskilled female. So here we have found the different number of unmatched individuals after the first round of match. So in the second round, we assume following the Fernandez entirely in 2005, we will still assume that the remaining unmarried skilled men, they are married and they are matched and get married with the skilled women. And for the remaining unmarried unskilled men, that match and get married with unskilled women. And they draw a new random match quality. And it's also a IID distribution. The IID draws from the same CDF function. Given the expected value of mu, and the support is Qmin and Qmax. So given the indirect utility function here, a skilled male is indifferent between accepting a first round of match with an unskilled female and reject that match and enter into the second round match if. So this is a payoff that the skilled male meet with unskilled female, and they accept this round of match with the reservation match quality equals to the expected payoff that he rejects this unskilled female, and he go to the second round and he meet with a skilled female and with the expected match quality mu. So we define here we found the indifference condition between the first round and the second round. So the equilibrium is determined by 8 reservation match qualities in the first round. So in the first round, a skilled man match with a skilled woman will be indifferent if, like I said, if this skilled man meet with a skilled woman with a reservation match quality, if he reject this type of marriage and this skilled man, he go to the second round of match and he meet with a skilled female with the expected payoff function equals to the right-hand side equation. And so the expected match quality equals to mu. And there will be the case that he can meet with no one in the second round. So this skilled man, he rejects the first round of match and he go to the second round, but he cannot meet any female in the second round. Then he will be single. So this is the expected payoff that he will be single. So here we define the two boundary conditions of the indifference conditions. So we do the same thing for another 7 reservation match quality. For instance, if a skilled man meet with a skilled female with the reservation match quality QF SS equals to the expected payoff that she rejects this match and she go to the second round. He meet with a skilled man. So we do the same thing and we define the 7 reservation match quality. We define the 8 reservation match quality for different types of agent in different types of meetings. So once we define the equilibrium conditions, here we have to find the equilibrium distribution of the households. We use the pi lazy to stand for different types of households in population. So we have the number of skilled husband with skilled wife in the population equals to this part. The first component corresponding to the marriage that take place at the first round. So this types of meetings happens and the times the probability that they agree this type of match. So they form the households. So this marriage happened at the first round, and plus the marriage that happens in the second round equals to this part. And also we do the same thing for the skilled husband with unskilled wife, and unskilled husband with skilled wife, and unskilled husband, unskilled wife in the population. So we have list different number of couples, different types of couples in the population. And also, since we have more numbers of males in the population, so we have the number of unmarried skilled male after 2 rounds of match in the population equals to this part. And the number of unmarried unskilled male after 2 rounds of match. So notice that we assume that all females, they get married. So the number of different types of household, the summation equals to the number of females. And also the if they plus the number of males, the number of different types of males, the equals to 1. That is the number of males in the population. So here it's equivalent to the cleaning condition in the model. So here we want to construct the education correlation between different types of marriage by using the standard definition about the correlation coefficients, and we define 2 events. If the husband is skilled, we define it equals to 1. If the husband is unskilled, we define it equal to 0. If the wife is skilled, we define it equals to 1. If the wife is unskilled, we define it equals to 0. So by using the education correlation form, we can find and using the equilibrium distribution of the household, we can get the education correlation coefficient. So now let's go into the calibration and function form. So suppose that our utility function takes the log utility function form, and the match quality, they fall in the uniform distribution, and given the standard uniform distribution, and given the expected value equals to 0.50, and the number of females in the model is exogenous, and which for different genders and skill types is exogenous, and I get the value by projecting the lifetime income from the CHIPS 2013. So we divide the sample into 7 age groups. So from 25 to 30, that's the group 1. Group 2, 31 to 35. And I compute the mean income for different genders and the skill types of each group. And the discount factor will be this one. So this is following from the most literature that using the discount factor for Chinese case. That's one. No, and the share of skilled male and the share of skilled female, they calculated from the CHIPS and compute the share of between at the age 20 to 30, and then I take the means of the values. So as we can see here, the calibration. So the number of females takes the value from 0.80 to 0.98. And it comes from the population census data 2010. And for different types of wage, for different gender, we can see we normalize the wage of unskilled female equals to 1. And we have the wage of skilled male equals to 2.0579. And we have the share of the skilled male and the share of skilled female equals to 0.51 and 0.48. So now we have calibrated the model, and we firstly resolve the reservation match quality. So the reservation match quality Q bar, are illustrated here. As we can see, with the decreasing of the number of females, this implies increasing of the sex ratios, as we can find here, with the increasing of the sex ratios, this implies a increasing of male abundance. So for males, we found the reservation match quality for the meeting of skilled, and the reservation match quality for all males in 4 types of meetings. We found with the increasing of the sex ratio, they all going down. So this implies that in the model, that all males are less picky. So with the increasing of the sex ratios, they are less picky on the females, as they want to get married. So we found the reservation match quality, they all going down. And if we look at the reservation match quality, we found for the reservation match quality of in a meeting of unskilled men meet with skilled women, the reservation match quality for the female has the highest value. So this means she has the highest probability to reject this type of marriage. If a skilled female meet with unskilled female, then the cutoff love has to be higher to compensate her income loss. So these numbers implies that the females are less picky, they are more picky. Okay, we want to study how the sex ratios affect the assorted marriage. So in figure 3, in the part A, this is come from the data sample as I projected. So I found that as time forward, I found the sex ratio at birth increasing. And in the figure B, we found with increasing of the sex ratios, the education correlation between couples decrease. So this implies as time forward, the degree of assorted matching in China should decrease. And how does the model fit with the data? So if we compare the moments between the model and the sample, we found for the mean, the model quite fit with the data. And for the standard deviation for the second moment, we found the model generate a lower degree of the standard deviation. And in the data, we have higher standard deviation because in the data, we have some outliers. And how does this imply with the household income inequality? So I found with increasing of the sex ratios, the Gini coefficient decrease in China. So this implies as time forward, the income inequality in China decrease. Okay, if we look at 2 empirical evidence from the most literature published in Journal of Development Economics and Journal of Comparative Economics, we found they plot as time forward, the income inequality is volatile, but the general trend is decreasing in China. So this model explains that the sex ratio is negatively correlated with the household income inequality in China. And the result is consistent with the literature's finding. And once we employ different measures on the household income inequality, we also found a robust relationship between the sex ratio and the household income inequality. So there is an active relationship between the sex ratios and household income inequality. And lastly, we want to, if we endogenize the education decision, so before the agents, they go into the marriage market, they will decide whether they want to become skilled or unskilled. So this is to say, okay, if they are going to the marriage market and they know that, okay, in the future, we have more males to compete. How do we decide our education investment? So here I define the expected payoff function here. That is the expected value of the payoff that he get married with different types of agents, and plus the match quality he perceived or she perceived. So to get rid of the complex equations, I firstly using the decision tree to intuitively illustrate how the decision will looks like. So the decision tree for males who want to become skilled. So this is the decision tree for the males who want to become a skilled agent. So in the marriage market, in the first round, he could meet with a skilled female, unskilled female, or he meet with no one. So if we look at the first branch, if he meet with a skilled female, he can accept this marriage, or if he reject this type of marriage, he go into the second round. He will meet with a skilled female, or he will meet with no one, and he will be single. So this corresponding to the first branch. And in the second branch, we found that if the men want to become skilled, and he go to the marriage market, he meet with unskilled female, he can either accept this marriage or reject it, and he go to the second round. If he go to the second round, he will meet with a skilled female, and he also can meet with no one. So in this case, he will be single. And in the third branch, in the first round of matching, if he meet with no one, he will directly go into the second round match, meet with either the skilled female or either the meet with no one and be single. So this is a decision tree for the males who want to become skilled. And we also plot the decision tree for the females who want to become skilled. So here I want to, because the equation is too occupied on the lecture slides. So here I want to just give you some brief description on the expected utility function. So here, the first branch here, corresponding to the first branch, meet with a skilled female, makes the decision get married or not, and or go into the second round. And the second component, corresponding to the expected payoff, meet with unskilled female, makes the decision get married or not, and go into the second round. And the last component, corresponding to the decision tree on the last part, meet with no one and directly go into the second round match. So over here, we have found the expected utility of a male who want to become a skilled. So given the friction of the psi f is a skilled female. So actually we have 4 expected utility function for the agent. The expected, the skilled male, the unskilled male, and the skilled female, unskilled female. So here we have at least 4 expected utility function. So here I just only used one here. Okay. So here we also have the expected utility of being skilled female. The expected payoff function is listed here. So after we have found we list the expected utility function, and we take the some assumptions on it, and we solve it by using some numerical methods. We can find how the sex ratio affect the education attainment, education decisions. So from the left-hand side, this is from the model simulation. We found with the increasing of the sex ratios, the proportion of skilled agent increase for both male and female. So this implies, as time forward, the share of skilled male and the share of skilled female is increasing in China. So if we compare it with our census data, so if I plot by using the census 2015, I found as time forward, the proportion of skilled agent for male and female, they both increase. So this illustrates the model is quite fit with the data. And this is if we endogenize the education decision for the agents, they would react. How would they react if they can expect that future match market competition would be more intensive for males? So both agents will increase the education decision, education investment. So let me conclude this paper. So in this paper, we found that for females, they are more picky and males, they are less picky, with the increase of the numbers, with the increase in the number of males in the match market. And the sex ratio is negatively and significantly correlated with household sorting in China. So in the region of male abundance, we found there is lower degree of sorting matching. And also we found the rising sex ratio in the marriage market is associated with declining of household income inequality. So lastly, we found males and females are more willing to become a skilled agent with the increase of the sex ratio. So now I think that's end of this presentation. And if you have any questions, please feel free to ask me. And thank you very much.
好的，感谢我们的黄博士啊，给我们带来了一篇关于性别和劳动这个以及我们这个收入不平等的问题的一个研究啊。然后看我们的这个专家哈有没有什么想跟我们的黄博士进行交流的？黄博士，你这些文章还是在投稿阶段，还是说已经发表了？
在投稿阶段。
啊，这个投了哪个杂志的呢？
准备投稿到 Journal of Development Economics。
因为我看别专家没有提问哈，我这边有一个问题哈，就是因为知道这个你给出一些结果跟经验事实做个比较啊，比如说你做了一个基尼系数哈，就是收入不平等的这个结果哈，就是说你发现你的就是性别比哈，就是跟我们的基尼系数的那个降低哈，我们性别比的升高嘛。降低是这个是相关性啊，相关的，但这个可能你如果去说明它这个，你的结果跟事实相吻合的话，这个可能这个结果不一定有说服力，因为经济系数的这个降低可能跟我们的这个经济增长很多别的因素哈，这个社会的发展，对吧？如果你是把它归因于这个我们的性别比的提高，那么你这个就会给出一个。是不是可以给出一个这个隐含的意思，是说我们要降低我们的这个家庭收入不平等的这个情况的话，我们是不是应该增加我们的性别比呢？
首先的话是说这个，就是说基尼系数的下降，这个在这个就是说经验证据里面，在这个就是说大部分文献里面，它肯定是说受到很多因素的影响，就国家经济发展啊，还有说这些其他的一些经济政策。那么这篇文章里面就是说，从一个就是说家庭形成的角度，就是去解释，就是说，那么就是这个家庭形成对这个 收入不平等下降，它会有什么样的影响？因为当然很多因素会影响到收入不平等下降，但是这个家庭形成也会影响到那个收入不平等。那么这个机制的话是在西方的很多主流文献里面，他们都已经就是说有这个研究，那么就发现就是说，假如说一个国家它这个就是说夫妻间的它这个匹配程度越高，那么它对应的就是说一个收入不平等的上升。那么就是
对，
说在这
这个
个怎么去
这个应
理解它呢？
该机制都能理解哈，因为那个家
嗯，
庭它会差别会更大嘛，就是 skill 的
对对
skill 的 match，unskill 的
对对对
unskill match，这样的家
对对，
庭差距会很大，这个结果应该是可以理解哈。我只是说，如果
嗯
我意思是你的那个，如果要讲一个故事，而且把技
嗯嗯
术来对照，说你这个就是可以来解释啊，当然你这个技术吻合的非常好哈，但你可以说就是用这个因素来解释我们的中国的不平等的下降啊，就是说这样的话，别人就会说你是不是把我们的这个中国过去的反贫困斗争或者是对吧这些那些
嗯嗯，
其他
对，
努力都已经抹杀了啊？你说这个就是因为就是因为性别不平等导致的，这种恐怕就是我觉得感觉是不是不太好哈、就是对吧？
嗯嗯
那当然，这个作为学术研究的时候，你找到一个因素可以来解释我们的不平等的一个家庭不平等、收入平等一个下降啊，这是一个非常有意思的一个角度哈。但是
嗯嗯，
就是因
对，
为这个提的别的因素哈，我的
嗯嗯
那个问题就这样，然后
嗯，谢谢
我再
老师。
看别的专家有没有问题。因为我看你这个硕士是在英国利兹大学哈，那后来
嗯，是的。
博士去了南安普顿大学，你当初为什么不在利兹大学继续念博士呢？
嗯，就是考虑到以下几个方面吧，就是说一个奖学金，那么另外一方面就是说这个，嗯，难的话，这个老师他的这个研究方法和这个研究方向，那么跟我更加吻合，更加匹配一些。因为我个人的话，就是说更加喜欢这种数理化的，就是说这个就是说结构模型的开发，你包括它的这些估计，还去求解的话，那么比较热衷于去做这些事情。所以说然后另外一方面就是考虑到我的导师，他有很多高质量的期刊，那么就说在跟他这个学习的过程中，就是说在合作的过程中，那么我将来也希望就是把自己的这些成果，还有研究就发表到这种就说，国际一流水平上的期刊上。那么就说同时呢，他对这个中国方面的话题也非常感兴趣，包括他这个就是说，在这个因为计划生育政策导致的这个就说妇女的，劳动参与率，那么另外一方面就是说这个家庭形成啊、性别比啊这些，他对这些都比较感兴趣。那所以说就是我们想进行一个更多的合作。所以说这个当时我就选择了这个南安普顿这个导师，因为他这个，无论是从这个研究方向、方法，还有就是说他的这个成果，还有这个发表能力的话，我觉得都是非常理想的。所以说我就想，嗯，跟他学习，然后将来就说进行更多的合作，就是努力把自己的成果提高到一个就说更高质量的平台上。
嗯，好的，非常好，
嗯，
非常
就是，
好哈。这个我看那个您的那个这个 labor 哈，就 job search 那种问题研究确实很深哈，对模型的理解还有应用都很不错。这个你的这篇文章，从技术方面讲，肯定是我觉得是无可挑剔的啊。说这个模型应用很精彩啊，就是把那个，不管是从对实证的结果的相吻合，还有你的模型构建、求解哈，我也就非常精彩啊。这个如果别的老师没有什么问题的话，那我们就，
哎，等会儿，
嗯，
谁呀？吴老师？
哎，
哎，对，我那个，我刚才稍微有点事儿，完了呢，我就那个一下，然后
哎，好的，
我一直有个问题，就是说，呃，这篇文章最后得出了一个结论，说是什么呢？叫生育，好像是男女性别比是不是越高，然后呢叫收入的那个不去那个叫什么inequality 吧，就不平等就越低，是这意思
嗯，
吧？
对对对。
对，那这个地方呢，我有一种就是直觉是什么呢？ 而且你说那个收入不平等是指家庭收入不平等，对不对？是家庭的收入合起来，对
家庭，
不对？相当于说夫妻双方的收入合，对吧？然后再加上孩子的收入，啊，咱就说是夫妻双方吧，的收入合。比如说那生男孩家里头，咱假设现在是还是一个孩吧，就是说有男孩有女孩，说是这个整个社会上的这个男孩的比例越来越高，然后结果就反倒是家庭收入却不平等，却越低。那这个逻辑是什么呢？直
那么这个里
觉是什么？
面的，
嗯
老师，这是这样的，就说这个逻辑是这样的，就说我们发现啊，一个就说男性比例越高的话，那么就会导致这个将来他这个就是说结婚，那么跟异性他的这个教育匹配程度就会越低，就说 assorting matching 它这个程度就会越低。那么这个
怎么越低？
assorting
这个教育程度变是这个具体说是什么意思？就是男的教育水平低，女的教育水平高，是这意思吗？还是什么意思？
对对对，是这样。
那你别对，你具体说一下。你看，比如说，
嗯，
男性比例越高，然后所以说呢，这个
那么
男性的家长
夫妻
为了男性
间的教育
家长，
差距，夫妻间的
男
教育差距
性家长
会越大。
为了那个自己的儿子在这个婚姻市场上具有这个更好的竞争力，所以说对孩子的教育投入就偏高。然后呢，所以
嗯
说男的这个教育水平就高了，而女性家庭呢，由于女孩子的家庭呢，由于说女孩子性别比有在婚姻市场有优势，所以说对
嗯。
孩子的教育要求就不是太高，所以说呢，导致说男孩子的教育水平和女孩子的教育水平就差距就拉大了，是这意思吗？
对对，
我要的是这个逻辑，就是这个直觉，对，
嗯，
是这个
好的，
逻辑吗？
是的，是的，
这个我的感觉不对。这么说吧，第一条是
嗯
对的，比如说男性比例多了，女性比例低，对吧？那么男孩子
嗯
家庭嘛，大家都说对吧？那个谁未上进的，还有张晓波他们讲的逻辑很简单，对吧？就是为了
嗯
这个男孩子家庭的父母，为了让
嗯
自己的孩子在这个婚姻市场上有更强的竞争力，所以说呢，就给孩子对吧？就是很努力去工作，给孩子存了不少钱，对吧？说白就叫投资银行嘛，对不对？然后
对对，
男孩子呢，这个是一个逻辑。当然了，同时呢，为了那个而在孩子的教育上，对吧？也会投入更多，让孩子更优秀，男孩子更优秀，有竞争力，对不对？
嗯嗯
相对来说，那么这个是逻辑的。但是事实上呢，那女孩子家庭呢，难道就不是这样的吗？现在假设现在在教育上的投入，实际上也都是女孩子的投入也很高吧？
对对，所以说在最后这个部分啊，我们就是发现，就是说这个男性和女性他这个教育投资啊都会增加，但是男性的那个投入更多，
啊，
就是
你说是
幅度会比，
相对更多是这意思吗？
对对，
那就是说是男性呢，由于在婚姻市场上的竞争，越来越激烈，然后呢，男孩子他们的呃教育投入相对于女孩子来说是越来越高的，是这意思吗？
对对对，
那好，那
它
么这个
的增量
投入越
越来越高，
啊，
它的教育投入，就是说教育投入的增量越来越高，
对，增量越来越高。好，那
嗯。
这越来越高之后呢，怎么就会导致了家庭收入不平等性降低呢？
就是说这个他们之间这个配对的这个程度的话就会下降。那么就是说这个他们之间的教育差距，因为就是说男性他的教育增量越高的话，那么他们相比于女性，夫妻间他这个就是说教育差距是不是增大了？那么
对呀、
增大的话，就说就说我们叫这个 sorting matching degree，它就会说下降。
你这个又是按照你的模型去解释。我说直觉上是什么逻，
嗯嗯
就或者叫行为逻辑是什么？你比如说，男的孩子的教育水平相对女孩子教育水平，那么都偏高了。那么在婚姻市场匹配的时候呢，那么
嗯。
到底是这些受教育水平越高的男孩子，他和所匹配的女孩子是受教育水平是越高呢，还是越低呢？
这个的话，就是在模型里面，就是那就不说模型了吧，就是说直观来说，你男性的话，就并不是所有人他都是说一个 skill 的，就是说他并不是一个所有的女性并不是说一个高教育水平，还有很多低教育水平的。那么就说男性他会什么更加不挑剔一些，因为他就说你并不能保证所有的男性都能跟那个高学历的女性结婚，那么他会去选择一些就是说低学历一些女性。
这个我估计这个模
是啊，
型设置上
王老师，
是有问题。
我们的时间到了哈，我们下一位
好，
的那个，
OK，行吧，
对他这个
哎，好。
讲的故事是说，那个能挣钱的男的和能挣钱的女的概率更小一些，然后能挣钱的和不能挣钱的女的匹配，这样的话家庭差距可能就缩小了，估计是这样的一个，没有说肯定
那没错，这个没
问题。
错。如果是说这个教育水平越高的男孩子和教育水平相对低的女孩子的匹配的概率增加，这倒是
对对。
可以。可是呢，这是可以的，这就说得通了。可是，在我们所了解的感觉中，男的孩子受教育水平越高，实际上他真正匹配接触的却是什么呢？更优秀的一些女孩子。
嗯。
那这样来的话，这个故事就说不通了。因为如果夫妻双方教育水平都高，他们收入水平也偏高，反倒是
对对。
那个家庭不那个叫什么那个叫收入不平等就越强，对吧？
嗯。那么
是这
这个就要
样一个。
去通过这个就说实证数据，比如说分析最近几年，那么它可能会有一个就是说，在过去，就是它可能就是说随着时间，它这个匹配程度可能会不一样。老师您说就说最近几年就说越优秀的人跟越优秀的人匹配，那么我们就需要去通过那个实证数据去观测一下，就是说这个东西它这个随时间它到底是怎么样变化的。
好的，
事实上是
很感谢
这样的。
我们的那个王博士
你
哈，我带
对
来非常精彩的关于我们的性别比失衡的这样的一个研究，也确实也切合我们的中国的一些实际哈。然后这个我们就非常感谢黄博士的一个精彩分享。好的，我们下面的有请我们的另外一个嗯、这个学者哈，我看看，sorry。
好，
好，第三
谢谢。
个报告的那个是我们应博士，应博士，应博士来自香港大学，他是香港大学的经济学博士，研究方向主要是公共经济学、社会保障和养老保险以及人口经济学。他今天分享的那个论文的题目是禁止根据性别定价下的延迟年金，男性和女性社会福利的同时提升。好，我们有请殷博士给我们讲解他的一个研究。
好，谢谢吴老师的介绍。大家好，我是来自于香港大学的经济学博士应一楠。Thanks a lot for giving me this chance to present my job market paper, and very good to see some professors again today. Okay. Before talking about my job market paper, let me give a big picture of my research pipeline. I work on the public economics, social security, and demographic economics. In addition to my job market paper, I have several working papers under review. This one talks about the policy of mandatory annuity purchase in the defined contribution pension schemes. And this one talks about the unique needs of equilibrium in the annuity market. I'm also interested in the household finance and corporate finance. In terms of the household finance, I have a paper which talks about how do households hedge against the environmental regulation risk. And in terms of the corporate finance, I have a work in progress, which talks about how do the firms hedge against the political risk. It's my job market paper. If you have any questions and comments, please feel free to interrupt me. Okay. The title, Deferred Annuities with Gender Neutral Pricing, Benefiting Most Women Without Adversely Affecting Too Many Men. To someone who may not familiar about the annuity products, annuity products is actually a kind of insurance that transfers a lump sum wealth to a stream of steady income to retirees as long as they are alive. So annuity products can help retirees to hedge against the longevity risk. Longevity risk is the risk of outliving one's lifetime financial resources. Then proposing appropriate annuity-related policies will benefit retirees facing the greater longevity risk, especially in aging societies. And I have 5 sections to present today. First, introduction, followed by a model part with some assumptions. Next, results on the annuity markets and annuitants' welfare. Finally, the conclusion. Okay, let's start with the motivation part. This paper is motivated by an observed global trend, the political quest for gender equality. I find the annuity market is affected by this political quest. For example, more than 10 years ago, all members of the European Union have already banned the gender-based pricing in all insurance industry, including the annuity market. Recently, more and more states of the US also banned the gender-based pricing on insurance products. EU says that gender equality is a fundamental right for human beings, so it should apply to insurance market as well. It's believed that gender-based pricing will likely be banned in more annuity markets in the coming years. Now, let's look at how banning gender-based pricing affects the annuity market. According to the literature, banning the use of gender information in pricing annuities will cause a problem, the market efficiency loss. Why? In the annuity market, there is an asymmetric information on health between annuity providers and buyers. As a result, the problem of adverse selection appears with a high equilibrium price and low levels of transactions. While the observed characteristic of gender as an imperfect signal can reveal part of private information of health. So if the policy allows, annuity providers usually adopt gender-based pricing. Gender-based pricing means males and females are charged with different prices. And in this paper, in addition to talk about the policy effects of banning gender-based pricing, I propose an important solution to solve this problem by offering a specific kind of deferred annuities. What are the deferred annuities? Compared to the immediate annuities, also called as the standard annuities, deferred annuities ask individuals to purchase them earlier, several years before the retirement age, such as age 45. Then individuals receive the annuity payouts later, starting from the retirement age. So there is a period between the date of premium payment and the date of receiving annuity payouts. Now, why offering deferred annuities could be a potential solution to solve this problem? Because I find these two policies of banning gender-based pricing and offering deferred annuities link with each other. They link through the lens of heterogeneity of buyers' health characteristics and its resulting severity of adverse selection. Let's go into detail how those two policies link with each other. First, banning gender-based pricing. When banning gender-based pricing, males and females are put in the same pool to price annuities. Then there is an increase in the heterogeneity of annuitants' health characteristics. As a result, the market suffers from severe adverse selection. While on the other hand, offering deferred annuities can reduce the heterogeneity. Deferred annuities are available to younger individuals when their health information is less revealed. So at that time, younger individuals' health conditions are more similar to each other. Then there is a decrease in the heterogeneity of annuitants' health characteristics. Offering deferred annuities has the potential of reducing adverse selection. So in this paper, I studied the combined policy of banning gender-based pricing and offering deferred annuities. It's my research question. I studied the economic impact of the combined policy on annuity markets as well as annuitants' welfare. Literature part. This paper contributes to the literature of insurance markets with information asymmetry. First, according to the literature, banning the use of risk-related observed characteristics such as age, gender, and race in pricing insurance products will cause problems, including market efficiency loss and welfare reduction. In this paper, we studied the specific observed policy banning gender-based pricing. And in addition, the health levels. We will also incorporate wealth levels in this paper. Here, health levels are the risk types in the annuity market. And I will show wealth levels are also important to price annuities after the policy of banning gender-based pricing. The second part of the literature is the deferred annuity market. The seminal work by Giovanni in 1993, who studied the deferred annuity market. In her model, there are homogeneous individuals in the deferred annuity market. When deferred annuities are available, the private information is unreviewed, so all buyers in the market are the same. Well, in my paper, instead of the homogeneous individuals, I will also consider the gender characteristics, because gender can be observed by the annuity providers, even though the private information of health is not reviewed. So in my model, there are two gender groups in the market with gender gaps in health and wealth. Now the model part. I will introduce my model with some assumptions followed by the problems of the annuity buyers and annuity providers. Okay, the model part. I set up a three-period model with gender gaps in health and wealth. First period, period 0, working period. Individuals buy deferred annuities that are provided by the government. Period 1, early retirement period. Individuals buy immediate annuities that are provided by the insurance companies. Here we assume the different annuity providers because we want to keep our focus on the policy changes. Our result also holds if the deferred annuities are provided by the insurance companies as well. Next, period 2. Period 2 is the late retirement period with uncertainty. Uncertainty means not everyone will survive from period 1 to period 2. They survive with a probability, theta smaller than 1, larger than 0. So the longevity risk happens in this period. Individuals buy deferred annuities and immediate annuities to hedge against the longevity risk here. And only surviving pensioners can receive the payouts. Okay, the health levels in the model. I use the theta surviving probability from period 1 to period 2 to represent the health levels. Theta is the private information, also the source of information asymmetry on risk types. In period 0, theta is not revealed to the individuals when they are younger. Then in period 1, theta is revealed to individuals but still unknown to the annuity providers. But the annuity providers can observe the gender, and the gender can reveal part of private information of health because there is a gender gap in health. According to the empirical evidence, women have the longer remaining life expectancies at the retirement age 65. Now in the model, to capture the gender gap in health, I use a monotone likelihood ratio dominance assumption. This ratio, H theta F over H theta M, increases monotonically in theta. Here F refers to females, M refers to males. The probability of being females or males are the same. I equals to M of F. So H theta I is the probability density function of theta conditional on gender I. Now, this assumption is a quite frequently used assumption in the literature on information asymmetry. That means a female annuitant is more likely to be healthier than a male annuitant. Also, our assumption leads to the gender gap in health on average. The mean of theta for females is larger than that for males. Next is the gender gaps in wealth. According to the empirical evidence and the literature, on average, male retirees are wealthier than female retirees. To capture this gender gap in wealth, I assume Wi equals to G times WF, larger than WF, and the value of G is larger than 1. Wi is the retirement wealth level of gender I annuitants. Note here, we assume away the heterogeneity in wealth within a gender group. That means all annuitants of the same gender have the same level of retirement wealth. We have two reasons. First, the asymmetric information of health is the main source of the adverse selection in the annuity market. Second, keeping the gender gap in wealth, the value of G, will help us to get the sharp analytical results. And I will show these points later. Next, the annuitants problems. We have three periods, period 0, 1, and 2. In period 0, individuals choose the deferred annuities at the level of delta. Delta is the purchased level, and pay premium. Delta times this one, P delta over 1 plus R square, is the price for 1 unit deferred annuity purchase. Next, period 1. Period 1 is the early retirement period. In this period, individuals choose the immediate annuities at the level of alpha and pay premium, alpha times this one, P alpha over 1 plus R. This is the price for 1 unit immediate annuity purchase. Period 2, they receive the annuity payouts, delta plus alpha. And note here, there is a probability surviving from period 1 to period 2. Now, to solve these optimization problems, we use a backwork induction starting from the period 2. In period 2, they have no choice, so they just consume. In period 1, they choose alpha to maximize this objective function subject to budget constraints. Look at this objective function. The utility comes from consumption in period 1 and consumption in period 2. Also, there is a probability theta from 1 to 2. The consumption in period 2 is the remaining wealth in period 1 minus the immediate annuity premium payment. Now let's go back to period 0. The choice in period 0 is delta. So in period 0, anticipating the future optimal choice alpha, a gender I annuitant choose delta to maximize the expected value of U theta I. Now the optimal solution of delta is determined when its marginal cost equals to its marginal benefit. The first line is a marginal cost of buying 1 more unit deferred annuities. The second line is a marginal benefit of buying 1 more unit deferred annuities. Now, optimal solutions in period 1. In period 1, we find a threshold, theta alpha. That means that only healthier individuals with theta larger than theta alpha buy immediate annuities. Otherwise, alpha equals to 0. And in this part, optimal solution of alpha is determined when its marginal cost equals to its marginal benefit. Next, the total differentiation of equation 8 with respect to theta leads to the d alpha d theta is positive. That means the healthier ones within a gender group I buy more immediate annuities. Now, annuity providers. Annuity providers determine the annuity prices, and I assume the zero profit condition in this section. Zero profit condition means the premium received from all annuitants equals to the expected payment to all surviving pensioners. First, the government. Government is a provider of deferred annuities. Here we assume the government follows the zero profit condition on the ground that the governments have no profit motive in providing public pension schemes. We could find some supporting documents, such as in Swedish. Then the price of deferred annuity, P delta, is determined by equation 9. Next, the insurance companies. Insurance companies are the providers of immediate annuities. In this section, we assume a competitive private annuity market. That leads to the zero profit condition. Then the price of immediate annuities, P alpha, is determined by equation 10. Next, the results part. First, the results on the annuity markets. We choose the reference economy first. The reference economy is chosen without any policy change. The first policy we want to examine is a single policy of banning gender-based pricing. The second policy we want to examine is a proposed solution by me, the combined policy of introducing deferred annuities with gender-neutral pricing. Okay, in the reference economy, before any policy changes, the gender-based pricing is adopted and only immediate annuities are available. We can find some examples of this reference economy, such as Australia, Hong Kong, and Singapore. Now follow the zero profit condition. The immediate annuity price for gender I annuitants is given by equation 11. Here, P hat for gender I is price for gender I annuitants. Males and females are charged with different prices, P hat F and P hat M, and the notation hat is used to represent the corresponding variables in the economy before introducing deferred annuities. Next, the measure. We introduce a measure to study the market efficiency change, the severity of the adverse selection. Now, this measure is defined as the difference between equilibrium price and the actuarially fair price. In the reference economy, we use this one as an example to explain why this measure is useful. Okay, let's look at the general insurance markets. In the general insurance markets with information asymmetry, the adverse selection appears when higher risk types buy more insurance. We'll move to our focus, the annuity insurance market. In the annuity insurance market, health levels are regarded as the risk types, and healthier levels are classified as the higher risk types. Because the healthier ones, they receive the annuity payouts over the longer period. So they are classified as the high risk types by the annuity providers. Then adverse selection appears in the annuity market when the healthier ones buy more annuities. Now we find this positive correlation between health type and purchase level can be captured by the covariance between theta and alpha conditional on gender I in this measure. So the positive value means higher risk types within a gender group buy more insurance. Then the market suffers from the adverse selection with a higher equilibrium price. On the other hand, a negative value means healthier ones buy fewer annuities. Then the annuity market has the advantageous selection with a lower equilibrium price. Now, proposition 1, the results of banning gender-based pricing. After banning gender-based pricing, the price changes to P hat. P hat is same for both males and females. And we find there is an increase in the equilibrium price for male annuitants, but a decrease for female annuitants. The price P hat F decreases to P hat, but the price P hat M for males increases to P hat. And this ranking is proved based on our assumption, MLR assumption, which talks about the gender gap in health. And our result is consistent with the literature. Banning gender-based pricing has a redistributive effect. It benefits females but hurts all males. Now, part B gives us the measure of the market efficiency under gender-neutral pricing after this single policy. The difference between equilibrium price and actuarially fair price is given by equation 14. Here under gender, we find that this measure is quite similar with that under gender-based pricing. The difference is here. It's the conditional covariance over conditional mean, but for this one, it's the unconditional covariance over unconditional mean. According to the law of total covariance, this conditional covariance can be decomposed into two terms, the expectation of covariance and the covariance between expectations. This one is positive, But for this unconditional covariance, it has an ambiguous sign. Why? Because this term, the covariance between expectations, is ambiguous. And I will explain their economic meanings in later part when it's compared to the measure for deferred annuity market. So move to the focus of this paper. My proposed solution to solve the problem, the combined policy of introducing deferred annuities with gender-neutral pricing. As we discussed before, banning gender-based pricing increases the heterogeneity, but offering deferred annuities reduces the heterogeneity. So in this section, I will examine whether a counterbalancing effect will happen by introducing the combined policy of these two. Now, deferred annuities are introduced in period 0 with this restriction. The price of deferred annuity is smaller than the price of immediate annuity before the policy change. Let's consider what the functions of annuities. Here, deferred and immediate annuities perform the similar function in ensuring against the longevity risk. So if this restriction does not hold, the deferred annuities are not cheaper, then individuals have no incentive to purchase them earlier. They will wait when their health information is reviewed. Then introducing deferred annuities would be totally ineffective. Next, proposition 2. Proposition 2 gives us the results of this combined policy. We find the transactions in deferred and immediate annuities coexist. Second, the price of deferred annuities in equilibrium is smaller than that of immediate annuities. First part, this one contrasts to the literature. By Brugiavini, the immediate annuities would be totally crowded out by introducing deferred annuities under gender-based pricing, while we find the coexistent results under gender-neutral pricing. Here, part B, why the immediate annuities price is higher. Look at the period 0, all individuals buy deferred annuities. Now move to period 1, only healthier ones buy immediate annuities. So the immediate annuity market has more distortion and its equilibrium price increases. Now part C of this proposition gives us the measure of the market efficiency. We find this difference between equilibrium price and actual regularly fair price is given by 17. It's the product of gender gap in health and in purchase level. First term, gender gap in health. This one is positive. The female group is wealthier than the male group on average. So the female group is classified as a high-risk group by the annuity providers, and the male group is a low-risk group. Second term, the gender gap in this purchase level. In this purchase level, it has an ambiguous sign because its sign depends on both health levels and wealth levels. In terms of the wealth levels, compared to the female group, the male group is wealthier with a higher value of WM. That leads to the male group purchasing more annuities. Delta M is larger. Then this measure has a negative value. Now, on the other hand, in terms of the health levels, compared to the female group, the male group is less healthy, with a lower value of theta bar M. That leads to the male group purchasing fewer annuities, delta F larger than delta M. Then that leads to the positive measure. So we can conclude now, when the effect of the gender gap in wealth is stronger, this one is stronger, leading to the low-risk male group buying more annuities, then the negative measure appears. Negative measure means the advantageous selection appears with a low equilibrium price. Second, we compare the measures under two gender annuity markets under the gender-neutral pricing. We find both of them, the lambda, can be decomposed into two terms, lambda WG and lambda BG. Lambda WG means a within group term. lambda BG means a between group term. Okay, let's go into detail how we got their values. First, lambda WG. Lambda WG is a weighted average. Here, beta F is the share of purchase by female annuitants, and 1 minus beta F is the share of purchase by male annuitants. And the covariance between theta and gamma captures the correlation between risk type health theta and the purchase level gamma within a gender group I. So lambda WG is a weighted average of the effects from female group and male group. Now the values for those two annuity markets. First, in the immediate annuity market, d alpha d theta is positive. That means a healthier one within a gender group by more annuities. Then their covariance between theta and alpha conditional on gender I is positive. That leads to the positive value of lambda WG. While in the deferred annuity market, d delta d theta is 0, because when deferred annuities are available, health information theta is not reviewed. So the correlation between health type theta and purchase level delta within a gender group I is 0. That leads to the 0 value of lambda WG for this deferred annuity market. Next is the between group term. The between group term in both annuity markets, lambda BG, is a product of gender gap in health and purchase level. First, gender gap in health. This term has a positive value. Theta bar F is larger than theta bar M because the female group is healthier than male group on average. Then the gender gap in purchase level. As we discussed before, this gap has an ambiguous sign because it depends on both health levels and wealth levels. So we can conclude in both annuity markets, due to the gender gap in wealth, G larger than 1, the low-risk male group may buy more annuities, leading to the negative value of lambda WG. Now let's go back to this table 1, the values for those measures. Here, lambda WG positive for immediate annuity market, 0 for deferred annuity market, and the lambda BG between group term could be positive or negative. That leads to the lambda could be negative. As we discussed before, the positive lambda captures the effects leading to adverse selection because there is a positive correlation between risk type and purchase level. While on the other hand, the negative lambda captures the effects leading to advantageous selection because there is a negative correlation between risk type and purchase level. Now, due to the presence of this between group term under gender neutral pricing, we find the negative value is possible. So advantageous selection is possible under gender neutral pricing. And then due to the absence of lambda WG for this deferred annuity market, the deferred annuity market is more likely to have this negative value. That means it's more likely to have the advantageous selection with a low equilibrium price. Now our proposition 3 compares the reference economy and our economy after introducing the combined policy. First, we find the female annuitants always face a lower price. Second, a male annuitant may face a lower price when this sufficient condition holds. Look at the left-hand side of this sufficient condition, the gender gap in health. Here, theta bar F is actually the upper limit of P delta. Let's recall the equation to determine P delta. P delta is the weighted average of theta bar F and theta bar M, and theta bar F is larger. So when theta bar F